You are listening to Kubernetes Bytes, a podcast bringing you the latest from the world of cloud-native data management. My name is Ryan Wallner, and I'm joined by Bhavin Shah, coming to you from Boston, Massachusetts. We'll be sharing our thoughts on recent cloud-native news and talking to industry experts about their experiences and challenges managing the wealth of data in today's cloud-native ecosystem. Good morning, good afternoon, and good evening, wherever you are. We're coming to you from Boston, Massachusetts. Today is May 15th, 2024. I hope everyone is doing well, better than me, and staying safe. Let's dive into it.
Why better than you, Ryan? Come on.
Well, yeah, Bob and I were just talking about this. I just got some x-rays today from a 9-day-old mountain biking accident, and I have 3 broken ribs. So yeah, it's been a painful week.
It doesn't sound fun at all. Like, come on.
Listen,
dude.
It was fun. And I still, like I said, 11 miles after that, I still biked. It was probably just mostly adrenaline and shock, but I'm still pretty proud of it.
Yeah, you'll just be out for the next 4 weeks, hopefully taking it slow, and then
I know. Taking it slow, slowing down, that's hard for me. I'm going to go through withdrawal of things on 2 wheels, I feel like. To a certain I can probably still do the Peloton.
Yeah.
I can still do the Peloton.
Yeah, that's true.
Yeah. I've done that a few times.
And even if you want to go outside, just go outside and do a hike. Like, go for a walk instead of jumping.
You think so, but
hills,
walking is less comfortable, I feel like.
Okay.
I mean, breathing, I got that down. So nice. We're good. What are you up to? How you been?
I've been good. Last week I was at Red Hat Summit in Denver. So that was
that's right. How was that?
Fun show. A lot of focus was around AI for sure.
Not a shocker. Not a shocker. How much was OpenShift AI's stuff talked about?
Yeah, so OpenShift AI was definitely brought up, but I think their main focus was around something called Instruct Lab, which is their open source way of allowing users to download models from Hugging Face, and then they have a neat little way of, instead of building RAG, you can they have a way that you can fine tune models. So once you download a model, you can define a knowledge base and specific taxonomy. And again, these are all their terms. Once you feed it some data, you can actually ask one of their models to generate synthetic data based on what you gave it as a knowledge base.
Okay.
And then you can retrain the model for your specific use case. So again, it's all open source, similar to like everything Red Hat does. And they also announced like a couple of LLM, also speech and code assistant models with IBM Research. I think they're called Granite models. Just Red Hat throwing its actual hat in the ring for having its own version of open source models as well. So overall a fun conference. And then they did highlight like OpenShift Web Console, the UI for OpenShift that we are all familiar with, right? They have a new chatbot kind of an assistant that shows up in the Web Console. Like,
what does it help you do? Does it do troubleshooting or just like how to use the?
So it's alpha right now. The use case that they demoed during the keynote was more around, I need to auto scale my application. How do I do that? And it gives you like
answers, but it doesn't proactively do that.
It doesn't perform the actions for you. It just gives you like how you can do certain things. One cool thing that I liked about it was you can deploy it from the operator hub. It just shows up as a different operator, so you can choose to install or not install it. Sure. But you can also switch up the LLMs that it's using on the back end. So you can use their an OpenAI model, or
so you as the user can select which one.
Yeah, the user can select which LLM they want to use to back up the chatbot, like to be the intelligence behind the
from
chatbot.
A list, or can you like also pull in your own?
No, I think they have a certified list. I think they showed OpenAI and their own model as the 2 out of the 3 examples.
Sure.
But yeah, cool. I'm hoping like more and more open source models will get added, right?
Yeah. I interacted with a new support chat AI today. Okay. I'm moving, and so I had to like set up gas service and Eversources in Massachusetts, and they had like, this is the new and improved, like, so her like the chatbot's voice was well spoken and all these things, but terribly unhelpful again. I'm like, this is not improving the process.
I wouldn't expect Eversource to be there on day one, dude. They still
I'm just saying I lost a little hope in how these things are being implemented, but 2 out of 10 ever source, just saying.
Yeah, eventually we'll get there. Yeah, I think for some of these things, a basic website works. Like, okay, enable the service, enter your address, and that's it. You don't need a half an hour conversation just to figure out.
Here's the thing, the old chatbots, they used to, if you said like, let me talk to a representative, they'd immediately just send you off to a representative. This time, little like chatbot Sally or whatever her name was really persistent. I said, can I speak to your representative? She goes, it'd be really easier if you could let me help you again. And so 3 times, I had to ask 3 times for a representative. I was like, oh, chatbot's got some spunk to her.
I know. Yeah. There has to be a -- force flag. Like, come on.
That was unexpected. So anyway, we have a fun guest. We'll introduce him in just a minute, but it's all going to be on sort of like service meshes and stuff like that. You'll probably know the company, but before we get into who that is and what the topic is, why don't we dive into some news? Bhavin, why don't you kick us off?
Yeah, for sure. So similar to last week when we covered like a lot of acquisitions and funding rounds, we have some more this week, which is obviously good to hear for our ecosystem, right? So continuing from last time, Wiz Security, we discussed a lot about those guys and how they acquired Gem Security and were in talks to acquire Lacework as well. They announced that, okay, they have raised another $1 billion at a $12 billion valuation. And I'm sure, like, obviously 350 million out of this billion goes to Gem Security, but still, like, they are, I don't know, strengthening their war chest and then just consolidating all the different smaller vendors to help them reach that $1 billion ARR goal that they have before they go public. So congratulations to everyone at Wiz. Like, $1 billion is not a chunk change of money. Like, it's a substantial amount of money.
Certainly not.
Yeah. Hopefully you spend it wisely. Like, it's interesting that even in 2024 people can raise this much money, right? I know we saw Sneak back in 2021 raise $1 billion at more than $10 billion valuation. But that was the COVID era and everybody was getting funded and everybody was getting a lot of money. Wiz being able to raise $1 billion right now is good. So if you are in the Kubernetes security ecosystem, there are definitely vendors out there that are still hiring and still growing and still scaling.
Nice.
Next up, one of our previous guests, Loft Labs, the company behind the open source project vClusters, raised a Series A of around $24 million. So they are just going all in. I think they found their product market fit, or they found a product that the community loves and wants around virtual clusters, around vClusters. And Ryan, I know we discussed their partnership with SUSE around the ability to deploy vClusters on Rancher, and then how they also integrated with a local CSP in Europe. I think this all just shows the power of the vCluster technology. And congratulations, Lucas and his team at Loft Labs for this new money. So exciting times for them for sure.
Yeah, definitely a cool project, cool company. I think the whole virtual Kubernetes cluster itself is super valuable, especially in sort of like the dev test and stuff like that. But I know they're pushing towards production more and more and that kind of thing. So,
yep. And then more funding rounds, or in this case, it's more around like raising an equity, a debt financing round. So Harness.io, a vendor in the CI/CD or our continuous delivery space inside Kubernetes or inside the CNCF ecosystem, raised a debt financing round of $150 million. Again, looks like from a different articles, this might be the last quote unquote private round that they raised. I know they didn't have to give up any equity for this round, just debt financing from Silicon Valley Bank and Harness and Hercules Capital. But yeah, this basically gets them in a position where they can scale as much as needed before they are ready to go public. Looking at one of the articles, they also crossed the $100 million ARR last year. So these are substantial revenues and ARRs for sure. So I'm hoping once the floodgates open for different IPOs, we might see some of these companies be in the line or in the queue to go public and, I don't know, raise more money.
Absolutely. Good for them.
Yeah, and then finally, Akamai, right? Like I know we have had Steven Rust on the podcast a couple of times, but yeah, Akamai is in the news. They acquired another security company or a security company called No Name Security. And this is an interesting use cases or acquisition as well, right? No name security has been around for some time, and last they raised some money in December of 2021 at $1 billion valuation. So a lot of money, obviously. It sucks that now they got acquired for like $450 million, but at least they got an exit. Like we all know that the valuations were pretty inflated during the COVID era or the ZERP era. Still getting an exit, and Akamai definitely would do great with it. But yeah, just wanted to share that with our listeners. Like $450 million for no name security, now part of the Akamai security suite.
Yeah, and speaking of Akamai, I know we just spoke about how not too long ago they acquired Ondat, right?
Yeah.
And they're just, I guess, buzzing away because they also announced recently this week, I think,
Mm-hmm.
that they're acquiring the Red Cube's Tomi project or company, and we've had them on the show to talk about their platform,
Mm-hmm.
and I've had some hands-on experience with it. When we did a bunch of episodes on platform engineering,
Yep.
this is really about sort of like simplifying using Kubernetes and all the layers that go into it. It's really sort of a layer on top of Kubernetes, where you can kind of pick through sort of this marketplace and deploy things really easily and have sort of a zero to production
Mm-hmm.
style platform within a day,
Yeah.
and probably sooner if you're familiar and know the different layers and everything. So I know I had a good time using the product, and it seems like Akamai is really pushing for doing a lot. I'd love to see, fast forward like 2 years, what Atomi is going to morph these acquisitions
Yeah.
into when it comes to their cloud platforms and everything, right? Security, platform engineering, storage, and
Yep.
everything they already had to begin with. So
Do you
really
see them rolling
exciting
out like
stuff.
an on-prem solution with an IDP, or do you see them like enhancing their like cloud portal with IDP like functionality?
Yeah, I mean, I think it could be definitely both,
Okay.
right? Atomi is such a sort of flexible tool set that
Hmm.
I could see, their customers on prem definitely taking advantage of it.
Yeah.
Their cloud stuff, it might take more to inter
Hmm.
sort of twine those things, or maybe it'll be deployable from their cloud-based systems or something like that. But yeah, I'm excited for what that looks like. I think it makes a ton of sense just given how popular platform engineering is and how people want to get bootstrapped on that
Hmm.
type of an environment. So at the end of the day, if you're building straight off cloud, you still have to build a lot of it yourself. So
Oh, yeah.
yeah, good move for them, I would say. Congrats to everyone over at Red.
I know. I'm excited, right? Like we are seeing a lot of new funding rounds and some consolidation in our ecosystem. It's like there is a space for all of these vendors, and hopefully everybody can have a great exit or a good exit. And I don't know. We keep the products around. Like we.
Yeah. Well, not everyone.
Okay.
That's just the way it goes.
Come
But if
on,
you're in
man.
one of those looking
Yeah.
to be acquired, I hope the best for you.
Yeah. Awesome. Okay. Yeah. Let's introduce our guest and talk about what we have in the agenda today, right?
Sure. So Christian Posta, he is the VP and Global Field CTO at Solo.io. So
Mm-hmm.
Solo's been around for quite a while. They're sort of all up in the service mesh space with Glue and Ambient Mesh and all these things that have been around for quite a while. They have great
Mm-hmm.
products, and we're really bringing Christian on to get his expertise in sort of how service mesh has evolved over the
Yeah.
time and sort of where it fits into the world today and maybe where it's going and what challenges and sort of hurdles it's overcome. So, yeah, I guess without further ado, let's get Christian on the show.
This episode is brought to you by our friends from NetHopper, a Boston based company founded to help enterprises achieve their cloud infrastructure and application modernization goals. NetHopper is ideal for enterprises looking to accelerate their platform engineering efforts and reduce time to market, reduce cognitive load on developers, and leverage junior engineers to manage and support cloud mandated upgrades for a growing number of Kubernetes clusters and application dependencies. NetHopper enables enterprises to jumpstart platform engineering with KAOPS, a cloud-native, GitOps-centric platform framework to help them build their internal developer platforms or IDPs. KAOPS is completely agnostic to the Kubernetes distribution or cloud infrastructure being used and supports everything including EKS, GKE, Rancher, OpenShift, etc. NetHopper KAOPS is also available on the AWS Marketplace. Learn more about KAOPS and get a free demo by sending them an email to info@nethopper.io or download their free version using mynethopper.com/auth.
All right, welcome to the show, Christian. It's really great to have you here. Thanks for joining Kubernetes Bytes. Why don't you give our audience a little bit about who you are and what you do?
Sure. Thank you all for inviting me here. So my name is Christian Posta. I'm the Global Field CTO at solo.io. We can talk a little bit about what that title really means.
Sure, yeah.
But I've been here for 5.5 years. Before that, I was at Red Hat. And I've been generally working in the integration and distributed system space for the last 20-something years. The last 10 or so, been involved in Kubernetes, from the very early days at Red Hat. And then, helping organizations modernize their infrastructure, their application architecture, and actually making progress. Because I worked at big banks and working, in the past where I would see, organizations invest a ton of money in new technology and just end up in the same place that they're, being started with. But so I want to see progress. The last last 7 years, I've been working on what I think is the more interesting part of modernization is how do things connect with each other, and how do you secure that and all that.
Yeah, I think that makes a ton of sense. I think just in the past year, we've been talking about multi-cloud and multiple clusters, probably more so than the previous year on the show itself. And yeah, banks, they're slow boats to begin with. So any progress, I feel like, can be quite a win there. So tell me a little bit more about what field CTO really means, right? I've heard that term. I've seen it sort of manifest in different ways at different companies, but I'm interested.
So I guess different organizations, from what I've seen, treat the role of field CTO slightly differently. Some organizations might think of the field CTO as, a general technologist who's really good at sales and reports to the CRO or something. Here at Solo, I would say, actually, when Edith Levine, who's the founder of Solo, when we were talking back in fall of 2018, I was like, all right, I'll come over, but I want to focus on technology. I don't really want to deal with customers. Yeah. But when you join a startup, and it was early, I was employee number 10 or something. So you kind of have to do whatever the startup needs, right?
You'll get a hat as a title, but you're guaranteed to get a lot more hats.
Exactly. Yes. So I've gone from helping build the field organization at solo.io, helping, work with Edith on, what customers see, what they're looking for, helping with the product, some of the evangelization parts, public speaking parts. So I've sort of gone, around and done a bunch of, I've worn a lot of different hats here. Gotcha. And that's just a catch-all title, I think, for what
sounds like a fun one, honestly.
Yeah, it's been good. It's been a great ride. It's been a lot of fun.
Awesome. Okay, so that was, I guess, a great tangent to take, but I want to come back to the topic of for today, right? So, Christian, I saw that you had a session at KubeCon Paris as well around service meshes. So why not so I'm we're glad to have you on the show to talk about it, but I wanted to start with a 101 description, right? If somebody was living under a rock, or if the service mesh and networking wasn't their forte, they were focused on storage, which most of our audience is, what is a service mesh and how can it help users if they are building on top of Kubernetes?
Yeah, good question. So there's the dictionary definition of what a service mesh is, right? and anybody can go Google that, figure that out. But I like to explain it by way of example. And I think some of the origins for why a service mesh like thing was created in the first place comes from Google. Okay. And we're, it's although we have a lot of the folks who originally invented Istio, which is one service mesh that we might talk about today, but that are employees here at Solo. And watching what happened there. So they started off, Google Cloud and the API infrastructure that they've built, they followed a very similar path that probably everybody follows when it comes to, hey, we're building APIs. We want to expose them to other parts of the organization, potentially partners, outside users, open up our API catalog, whatever, right? As a big centralized API management system. That's how they started. And they started to run into the more APIs they built, the more varied of the APIs that they had. So not just REST, but gRPC and all these other formats. And, the criticality of these APIs, they realized that funneling all of those through a centralized system is not ideal. And they eventually did hit that not ideal state, which was outage. Big, massive outage.
Crawling to a halt, yeah.
Exactly. And that affected them significantly. And so their approach was, and they already started doing this, all right, well, we'll just carve off the important APIs over here on this API infrastructure, and we'll put this over here. But then they realized that a lot of that still depended on shared pieces and dependencies that if those go down, you still lose everything. So what they said is, all right, well, why don't we just take this to the logical conclusion, which is basically a little gateway and separate infrastructure for API management per service, almost per endpoint. And that will give the best resiliency. We can tune configuration specific to specific APIs without worrying about noisy neighbors and all this stuff. We can scale, we can deploy it geographically, and so on. So that's the approach that sort of pushed in this direction. And when people started deploying Kubernetes and microservices and all this stuff, we started to see a lot of the same forces at play here. And so now, the answer is, it's a more optimized infrastructure for managing APIs at scale and doing things like securing them, rate limiting them, observing them, controlling their traffic, shifting traffic, being very load balancing, and that kind of stuff. That either you put in a centralized API gateway or you put directly in the applications. But with the service mesh, you get the best of both worlds, basically.
Okay. No, I like that, right? Because if I'm coming new into the Kubernetes ecosystem, like services and different service types allows me to connect different parts of my distributed application together. But the benefits that you just listed, right? Like the traffic routing, the observability, the security, I think that's where service mesh becomes really crucial. So if you are getting started, I think you need to figure out what your answer is. And it can, like, I know we have spoken, Ryan and I did like an episode more a year back at this point.
We did our best.
From a service mesh 101 perspective. So I think I'm looking forward to this deep dive.
Yeah. Sure. I think that's a really good segue, Bhavin. So appreciate it. To the next question I had, which is, service mesh has been around for quite some time. I think the advent of just containers and microservices and more people using those architectures, we started seeing sort of the pain as you described in that case, and needing a solution for it. Service mesh has been here, I think. I don't know the amount of years, you probably do, but how has service mesh sort of evolved over time since when it showed up in cloud native to today, I guess?
Well, there's been an evolution, I would say, on a couple different levels. The first and probably most obvious is how it's built. Because originally, so the first official service mesh that we think about in this space was Linkerd. And they came out with a model that's sort of a shared node proxy model, and it was basically they just took Twitter finagle libraries, wrapped it into a container, and said, all right, this is everybody funnel your traffic through this, and deploy that on a node, on every node, and then Linkerd will connect that stuff. But that had some drawbacks from a security standpoint, from a noisy neighbor standpoint, from a there was upgrade in operations, all this stuff, and so shifting to sidecars was a natural evolution at that point. Again, sort of mirrors the way that the original story that I told you about how Google did that. That is exactly what they did. And then things like Istio came out, which was probably the first sidecar service mesh, announced in 2017, I think, May 2017. But Istio came and said, here's a bajillion features, you're probably going to need them. But that was very complex.
Sure, yeah.
And now we've seen the evolution of, both on the Linkerd side, they significantly simplified their implementation. Istio has significantly simplified the implementation, and we've gotten to the point now where just this week Istio released 1.22, which is significant because it's the first sidecarless service mesh that is now ready to be run in production. So that means you can get the benefits of MTLS and observability and traffic management, all that stuff, without co-locating sidecars now. It makes it much cheaper to run, easier to operate, easier to onboard, et cetera, et cetera. We can talk more about that. But so the first part is just simplifying the implementation of the service meshes to really focus on exactly the pieces that people need, that they need first, and then adopt the rest of the stuff. Otherwise, it gets too complex. Anything networking, if you just throw everything that networking can do, is too complex.
Yeah, I hear you there. And now is all this change that's sort of, or the evolution, has it been sort of a catalyst because of the adoption of service mesh? Like people started to adopt it and realized maybe they're only using certain features.
Yes,
that
so that's the second. That's the second piece is that people, first of all, back when Istio and Linkerd, all these started to come out in 2017, people were not ready for that piece yet, right? They were still going through, how do we containerize? I remember at Red Hat, it was, well, how do we lift and shift? And then when we do that, we have tools already that do deployment, for example. So let's try to use this IBM tool. I forgot the names of them, but and then we realized, okay, we can't really do that. We should automate things a little bit better and tie things into GitOps. Right? That was sort of a new idea. Then it was observability. Then people got to, all right, now we have our things we can deploy. Now we got to understand what's going on. Our previous generation tools didn't fit that well. They really monitored based on IP address and all this stuff, which doesn't fit real well in Kubernetes. So a new generation of tooling to better fit that came out. Now this last piece. So now when you go down this path, eventually you're going to hit the networking and security pieces. But you kind of have to go down this path. So when Istio and the service meshes came out in 2017, people weren't down that path yet. This idea of platform engineering wasn't really a thing. And now as we've made it, we're seeing, and I would say here at Solo, from a commercial standpoint, we've seen different waves, I would say, of spikes in very significant interest in service mesh. And I think we're right now at another spike. And I think things like Istio Ambient, the sidecarless mode, significantly lowers the hurdle for adopting the mesh, or adopting service mesh.
Okay.
So we're seeing a pent up demand as well as a spike anyway, but a pent up demand for what that might look like. So then we'll see from here.
Gotcha. So Christian, one follow-up question, right? And I love that you already started talking about platform engineering there, because that's where I want to go next.
Yeah.
But we spoke about the per node deployment that Linkerd started with, and then the sidecar mode. I'm glad that you shared that this week Istio is basically going the ambient mesh or sidecar less mode. So where is all this functionality provided, right? Like, is it running as a pod in the same namespace? Like, where does the service mesh functionality go if it's not in a sidecar?
Oh, from an implementation detail?
Yeah.
That's a good question. So I mentioned that the original, some of the previous implementations of service mesh started with a shared node local proxy.
Yeah.
Now, the challenges around that stem primarily around you don't know which workloads are going to be running on the nodes.
Mm-hmm.
End users want to configure the mesh and do all kinds of traffic routing, splitting, regular expression matching, like stuff that if there's conflicts on a particular node, because you don't know what's going to run at runtime, you're going to run into noisy neighbor problems, starvation problems, and we've seen this time and time. It's not theoretical. We've seen it. And the more that you allow users to configure the mesh for that kind of functionality, the more problematic it's going to be.
Mm-hmm.
So what we did with Istio is we said, all right, we're going to run a per node proxy, but it's not going to be any layer 7 stuff. Nothing that the user can configure. So that drastically simplifies what that implementation needs to do.
Okay.
And it just all the shared proxy, all that little agent needs to do is open a connection and establish MTLS. That's it.
Gotcha.
Right? And that forms the foundation for what the mesh ends up doing. Now, you want to get layer 7 stuff. We have another concept called a waypoint proxy that, once traffic goes in through MTLS, it can be forced through the layer 7 proxy, which can live somewhere else. Doesn't matter where it lives.
Yeah.
And so we get around some of those noisy neighbor problems, eliminate some of those problems. We do end up using a shared piece of technology, a shared agent, but it's no different than what your CNI is doing.
Yeah.
It's no different than what the kubelet is doing. You have some shared component, but it's so simple and so focused on one little, it's one thing to do, highly locked down and hardened and all that. And we feel that is an appropriate architecture to get the benefits that we then get with Istio Ambient.
Gotcha. And I like that, like, you split layer 4 and layer 7 functionality into different things, because not everybody would want everything, right? Going back to Ryan's point.
And that's one of the big observations and big learnings that we've taken away from Istio, is that, because like I said, in 2017 when it was announced, it was traffic splitting and AB and canary routing and MTLS and all, a whole bunch of stuff. When we realized, and actually I remember at Red Hat, we did a survey of some of the initial adopters that might be interested in Istio. And in my mind, I thought, safe deployments, rollouts, canary releases, blue-green deployment, I thought that would be the number one use case. It wasn't. It was security. That was then, and still today, when people look at service mesh, the number one, first use case that they want to adopt and use it for is the security pieces, MTLS, mutual authentication, that kind of stuff.
That's good to know. I think we need to make a note of it, Ryan. Okay, switching gears to platform engineering, right? I know you already gave us a good segue. We spoke about how different personas exist, and everybody shouldn't be like. We spoke about it from an application perspective, right? You don't have to build in the logic in the application layer or in the infrastructure layer. I think I want to reframe that to a question around personas. Like, inside platform engineering, you have a platform engineering team that's focused on building IDPs and providing a set of services to the end developers. How do you see service mesh fit in? Is it the platform engineering team's responsibility, or once they provide you a cluster as a service functionality, it's on the developers and the application owners to work or to deploy service mesh and configure all those rules?
Okay, good question. In my experience, we've seen, so first of all, I've seen both models. I would in my opinion, if I'm working with a customer right now, I would say do the former, not the latter.
Okay.
That things like service mesh, well, the idea that as a platform team, I'm going to put together a Kubernetes cluster and just say, hey, developers, go have at it. I think that's a really bad idea.
Okay.
And like I said, we do see this because it stems from the idea that, hey, well, you build it, you run it. And we've seen that taken almost to too much of an extreme.
Yeah.
And so I would suggest the former, which is your end developers, first of all, shouldn't know anything about a service mesh. They don't really care about that, and they shouldn't. What they want. So let me give you a good example, because I kept referring to service mesh and security as the top requirement. MTLS. When people hear that, they think, oh, the encryption part. We'll get everything encrypted, check some boxes on compliance, and that is important. But there's another part that developers might care about that the platform could offer and make it simpler for developers. So that is today, I know a lot of organizations, when they initiate service-to-service communication, they need to authenticate. So not the user comes in, they sign in, do their OAuth stuff, whatever, and that's all good. But for service-to-service, what they end up doing is passing some sort of JOT token or API key or something that says, hey, service A is talking to service B. So I'm service A, here's my JOT token. Service B, when you get it, you know that I'm service A because I'm giving you this token. Right? Okay. There's a lot of challenges to doing that right. I've written some blogs, did some talks on that, but in the short, it's that token is the secret material. You're putting that over the wire. Somebody captures that somehow or gets logged somehow, anybody can replay that. There are things you can do to mitigate replay, but now it's on your developers to have extremely good and tight JOT handling hygiene so that audience is set correctly, expiration set correctly, that you renew them, you use different JOT for each service, et cetera, that gets complicated. Now, if you can say that, hey, we have mutual authentication baked into the platform by virtue of MTLS, and Istio also uses Spiffy, which is a workload identity framework. Okay. We get automatic mutual TLS. You don't have to pass these JOT tokens back and forth to prove your service identity. That simplifies things quite a bit for developers. And they should know about that capability. They don't have to know about the service mesh or how all that works. So that's one example of how the platform can offer a place for developers to deploy their APIs, deploy their services, simplify some things, and not have to know about how all that stuff works.
Yeah, it sounds like there's like sort of a sweet spot. You mentioned over-rotating, giving developers too much responsibility, and the JOT token thing is a perfect example because we all know they're not going to set their expirations correctly probably all the time. Probably guilty of it myself.
Same.
But I guess there's the platform engineering team that comes back to them to sort of set up the secure by default and sort of default. And if you want to do more, if you're that kind of developer, maybe you can enable those things too.
Yes, absolutely. You got to find the right balance. Yeah, you don't want to swing in either direction too extreme.
Yeah. And Christian, this might seem like a really basic question, right? Let's say I want to extend this platform engineering conversation. Like, okay, I have a platform. Through my CI/CD workflows, a developer deployed an application. They didn't have to worry about authentication or security between or communication between different parts of the app. If I'm an administrator or the platform admin, right, who is configuring these policies and enforcing security or traffic routing, how do I know? Like, how does a developer tell me, like, okay, these are the services that need to talk to each other? Do they define it through a Kubernetes construct, a YAML file, a service mesh object? How does a developer, without having to jump on a Zoom call, tell me like, okay, this is the components that I want to communicate with each other?
Yeah, so that I would say is, the service mesh itself is not overly opinionated about how that gets done. What we end up seeing is a couple of different things. Either people they build either they have their own configuration files already, their own formats, and they might specify dependency type information there, and then that gets pulled into CI/CD, and then everything gets built off of that. But some organizations say, nah, you have to talk to the security team to make sure that that is approved first. So maybe they'll take that and they'll have some automation to get approval from the security team and so on. Some others, they built in their IDP, they've built a workflow that automates some of the approval processes and things, and to allow certain communications. And then those, at runtime, at execution time, whatever whether it's your proprietary config or a custom workflow or whatever it is, can then generate all of the Istio configs that are necessary to implement those policies. So generally the policies are organization specific, how they agree on those policies, and then the enforcement is implemented by Istio.
Okay, gotcha. Thank you.
That makes sense. I'm going to come back to a point you made earlier, which was that this world of sort of like networking and service mesh blend and sort of overlap in certain scenarios, and to a very good point, because they are related. But one thing Bhavin and I have done in recent episodes is talk to other networking companies as well, and the idea of connecting resources outside of Kubernetes comes up a lot, right? So, like a external database or another cluster or those kind of things. Sometimes it's done over, tunnels and those kind of things. So, does service mesh also do these things? Work with the networking pieces? What is the service mesh's role in those scenarios?
Yeah, so it works with the other networking pieces. Okay. It doesn't. So layer 3 connectivity, so the IP layer connectivity, it doesn't handle that. It will live on top of that.
Yeah, got it.
And connecting into VMs is a very important use case, because even the folks who use Kubernetes have probably a lot more stuff running outside of Kubernetes.
Sure,
yeah. And Istio has been able to support, for example, Istio has been able to support VMs for a while. There have been some, I would say, over the last year or so, maybe a year and a half, we've smoothed out some of the integration with VMs, because we see this use case a lot more. So connecting with VMs, definitely, first class use case that the mesh supports. To do that, you got to integrate with Spire for the workload identity stuff, which is, we see a lot more people kind of starting to adopt Spire and starting to adopt workload identity. So those pieces are converging very nicely. But then, you maybe it's difficult to run a full-blown sidecar, for example. So this is where Ambient comes into the picture and significantly simplifies extending the reach of the MTLS piece, because now, instead of a full-blown sidecar, you can just run the little MTLS agent, and in more places, I would say, and then connect into the mesh easier. The last bit is, well, what if you can't run an agent? What if you can't run extend the mesh all the way out to, you mentioned database or something, but there's still, or a use case that's coming up a lot more is around making calls out to other SaaS providers, for example, OpenAI or LLMs. So controlling and managing egress traffic has always been a under the radar type use case that the service mesh helps with, and things like controlling usage, rate limiting, all that stuff, straightforward. But things like credential hiding, right? If you're giving credentials to all these different clients and services that need to call outside APIs, those could get compromised. The developers could take those keys when they leave to go to a different company, et cetera, right? So can you create a secure tunnel from the apps, from the APIs internally, to an egress point that then handles credential mapping, right? So that's a very important use case. Things like even basic stuff like when we're talking to an external database, that has to use TLS and it has to come from a known network endpoint, known IP address.
Okay, yeah.
So forcing the traffic through an egress point at layer 4 and layer 7, addressing the MTLS pieces and all that stuff, then the developers don't have to worry about that. So both expand the mesh out to as far as you can get it, and then manage the egress traffic from the mesh to external endpoints. All very important pieces. Yeah.
I think that's super useful, right? As Ryan said, there are people that are running part of applications on virtual machines that on still traditional virtualization stacks, and maybe if I'm running in AWS, I'm using RDS or something, right? So the ability, like this, gives me an control over how my applications are talking to these external to the Kubernetes cluster components. Christian, you brought up virtual machines running outside. What about virtual machines running inside Kubernetes? Like I know with KubeVirt and OpenShift virtualization, even your previous employer, Red Hat, really is pushing or sharing stories around how OpenShift virtualization is successful. Can Service Mesh work with that today if people are evaluating? What are your thoughts there?
Yeah. So this is an area that admittedly I'm not super deep in, but I did ask so John Howard, who's number one contributor to Istio, who's a solo employee now, I asked him, he said that he knows of people that have been successful running that. So I think, and there are some specific settings inside of Istio today, so you could take it and run it today with KubeVirt. But that's the extent that I can comment on it right now.
I feel like with the agent that you explained before, right? It's essentially like a node using for virtual machines. You could see that agent running there, or even when you were talking about sort of extending the cluster before, I could easily think of sort of edge use cases, right? Whether that's some sort of compute or more containers or those kind of things. But I feel like that fits into the scenario.
No, absolutely. And that KubeVirt use case that I was referring to was with sidecars as it is today. Ambient changes the options there too.
Yeah, because so I've deployed KubeVirt VMs, but I don't know how to add a sidecar to a virtual machine object, right? Like KubeVirt deploys a pod which spins up a VM object. So that would be interesting. But again, as you said, sidecarless in ambient mesh mode, that's awesome. I don't have to modify my VM object. I can keep migrating them over from Rev or OpenStack or VMware, and then just use a service mesh that I've already deployed. So
for folks that are interested, like I said, I can't speak too knowledgeably about it here, but if they're interested, come to the Istio Slack. Like I said, the people have got it running successfully. There's a couple different options for doing it. The configs are all there. We can help.
The power of community.
Yeah.
We'll give you more of a chance towards the end as well to kind of throw any other resources out there as well. But that's a good idea for those specifically interested in virtual machines and KubeVirt or that kind of thing. Speaking of sort of other stacks or other integrations, when we spoke before this, you had mentioned the Cake stack, and I had never heard of it before. So I guess we'll start with sort of what is the Cake stack? Why does it exist? And where does Service Mesh fit in there?
Good question. So earlier I was talking about, sort of the pieces, what do they call it? I guess the Maslow's hierarchy of needs, sort of, you need containers, you need observability, and eventually you're going to need networking. The pieces that we see, so we as in Solo, I think working with our customers and taking things to production. What we end up seeing as sort of vital for the networking story is the layers that we identified in the CAKES stack, CAKES. C starting with actually, if you're starting with Kubernetes. That's the K part, right?
Yeah, gotcha. Okay.
Kubernetes, you're modernizing, you're building platforms. Kubernetes is the foundation. Now you need the containers to be able to communicate with each other. They need to send packets back and forth. So you need a CNI. That's where the C comes in.
Okay.
And just like the LAMP stack, you can pick one of the pieces. The P, for example, in LAMP, originally I think it was Perl, but then it could be PHP, it could be Python, It could be what, right? Yeah. Just that those pieces are known to integrate well and work well together. So in the cake stack, the C is for CNI, but CNI could be a specific one like Cilium or Calico or another one, right? It doesn't even have to start with C. But so you got Kubernetes, you have some CNI to enable layer 3 networking between and sort of coarse grain network policy in the CNI. But then you need more layer 7 application layer connectivity. You need MTLS. You need load balancing. For example, I don't mean just, hey, one endpoint's faster than the other, but I mean like smart zone aware load balancing. Hey, I'm going to keep things in the same zone, spill over to another zone or other region only if I need to, right? Keep costs, control costs in terms of availability. And so that's where the mesh comes into the picture. And in the cakes stack, Kubernetes C, CNI, A is for ambient. Okay. Because we want a low profile, cost-conscious way of solving these problems, and that's where the A for Istio ambient comes into the picture. The E, so CAKE, the E is for Envoy proxy, but what that represents is really, an appropriate gateway or ingress of traffic into the cluster, because you need that too. An API gateway or just an ingress to get traffic into the cluster. Envoy proxy was purpose built for doing that. Yeah. There exists other reverse proxies, and for various reasons or another, Envoy is best suited, we think, for that ingress layer.
For that piece, can you use basically the gateway API? It kind of built.
Yeah, exactly. So, the Kubernetes Gateway API, which just went GA back at KubeCon Paris or so, is a good abstraction for driving an ingress or a proxy or a gateway, of which, like I said, we believe the Envoy is best suited for that. The last bit is S, so cakes is S, and that stands for Spiffy Inspire. Okay. So the workload identity pieces. Like I said, these all kind of work nicely together. And I think there are 2 or 3 principles that they all kind of form around, and that is number 1, being driven by declarative configuration. Extremely important in this cloud native way of working and in our GitOps type workflows, etc. The second is standard integration points. We're not saying, like, if you adopt this, you're going to be completely networking panacea, right? We know that there are a big chunk of things we can do, but for other things, we can call out using standard integration points, things like open telemetry integration for telemetry collection, calling out to different authentication systems, maybe using OAuth or OIDC. Calling out into rate limit, calling out to OPA, Curverno, or your own custom policy agent. So knowing that we're not trying to solve everything, because we know that there's a lot of unique and nuances to how you implement networking, but providing standard integration points. And we think that's different from what the proprietary vendors have done, and much more flexible, much more beneficial. So Cakes is sort of the open source stack of networking components that come together to work well to solve modern networking problems.
And like, since you're part of this community, right? Like, has somebody already taken like a domain like cakes.org or cakes.ai? I don't know. That would be fun.
That is a very good question. I am not sure.
Okay. Or just invented a really delicious looking sticker, maybe.
Yeah, come on.
Right.
Opportunity there. So at the end of the day, this cake stack really helps organizations, based on what you've seen work really well together, become sort of more efficient in using this type of like standard stack, even though they can kind of mix and match a little bit of here and there, and that's beneficial to the organization because they, if the comes with a lot of things that work well together, then you're kind of ahead of the game. Hopefully,
they work well together, and they put you on the path to solving the problem. Like I said in the beginning, you can take old technology and try to fit it, not old in a bad way, but old in it wasn't built for this certain problem. It was built with different problems in mind, and you can take that stuff and try to shoehorn it in, but you're going to run up against challenges because of the mismatch. And these pieces were built for this era. They were built for this type of environment, and they were better fit that the problems that you're trying to solve in networking today.
Gotcha. Okay. And like we can't wrap up a podcast without talking about AI these days. So like here's the AI question for you, Christian. Like I'm not talking about like are you building like an LLM for inside Solo? This is more around how AI workflows and AI tools are helping maybe improve service meshes, right? So like if I have a service mesh deployed, do you see are there already projects or work being done, or do you see in the future where I have an AI agent per cluster or per my multi-cluster environment, and it is monitoring for like spiky traffic, like components that were not supposed to talk to each other, and now they're sending out requests, like somehow helping me make my environment more secure or make it better? Like, do you see that happening from an AIOps perspective?
So I see infrastructure like the service mesh as being a crucial sort of point of monitoring, right? You can pull back a ton of telemetry about what services are talking with what other services, which ones are failing. I just did a deployment. What's been the impact?
Yeah.
And if you pull that information back, you can put it into a model and start to detect or predict anomalies or predict things about that. That's one angle. The other is if you can predict and you can get good at predicting that, then the service mesh also represents a point of control. And, being able to then predict and then make changes and control, do traffic pattern analysis, and this doesn't look right. This is about to fail, so go flip these other switches and maybe contain this thing, or what, right? You can work toward becoming smarter about how you deal with the infrastructure and availability and cost and all of these other things. So having that connectivity tissue there from a observe and control standpoint is extremely powerful.
And maybe
you have like a service mesh digital assistant. We'll call her service mesh Sally, and you can ask her, which one of your services is making up the most traffic or something like that.
Service mesh Sally, that's SMS. Nice.
No, and Christian, like, do you see these services or these AI agents or Sally, for example, take over for you and be proactive at blocking things that things might happen, or do you still see like generating events and then and a human has to take over and fix things?
I think certain things it can help humans. The running and debugging and understanding what's happening in a distributed system and all the things that can go wrong is fairly complex, or very complex. And I think AI can help there, but I think the humans still need to. Because if something decides, all right, we're going to change the traffic and do all this stuff, and you take something out, that's going to be a big problem. If for nothing else, the executives want to able to point at somebody and say, "Hey, you did that."
Yeah.
Okay. But I was just kidding about that. But I think humans are still a very important cog in that big picture right there.
I certainly hope so.
Yeah.
Or at least I'd love to see some stats on how many times I'm using human in the past year, the word human in conversation. I feel like we're talking about ourselves a lot more these days. Anyway, so, we do want to give you a chance to sort of throw out some places where people can maybe find you, get in contact with you, or find out more about some of the projects you mentioned, or even like the Slack space you talked about, or other community spaces. So if you have any, this is a perfect time to, throw them out there.
Sure, I appreciate that. So yeah, I'm on LinkedIn. I'm on Twitter. I frequently speak at some of these large conferences like KubeCon and others. Actually, there's a new conference in Boston from the InfoQ folks. I think at the end of June that I'll be speaking at. And yeah, and generally the community access points like Istio Slack, Solo's Slack. Yeah, those are the big ways, and I'm always happy to, people reach out, or actually I put my contact information up on a slide at various conferences, and then people come up afterward and they say, "Hey, can I contact you?" I'm like, "Yeah, that's exactly why I put my stuff there. Please contact me. Happy to chat.
This is polite.
Happy to chat and go in in more detail on any of this stuff." But reach out anytime.
So for locals who might be listening to this podcast, InfoQ Dev Summit Boston,
That's
June
right.
24th, 25th. Is that the one?
That's the one. Yeah.
Perfect.
Yeah.
All right. We'll put a link to it in the show notes if you need more information as well.
Yeah.
Cool. Well, Christian, it was really a pleasure having you on Kubernetes Bytes. I know the more we do these types of interviews and sort of just talks, I learn more every day, and probably have just a giant running list of things that I got to go research myself. But it was very good, and hopefully our listeners thought so too. So thanks for coming on the show.
Absolutely. My pleasure. Great questions. Appreciated the interview here. Thank you.
All right, Bhavin, that was yet another great conversation with Christian. I think I learned a lot. I feel like I've been out of the service mesh space for probably a while. I know we did the 101 episode. We'll link that. I'm curious actually to remember what we covered in that episode. I'm like, can't really remember, but what were some of your takeaways from this one?
No, I think like last time when we did this, right, I agree that it was a while back and it was more of a 101 episode. We did cover the transition that you were mentioning. Sure. We covered, I think ambient mesh was still kind of new back then, and
right.
we didn't
getting
even
away
talk
from
about
sidecars and everything. Yeah, we did talk about that.
Yeah, and we didn't even bring up Istio and its sidecar-less architecture or sidecar-based architecture back in our 101 episode. So it was good to hear that even Istio now supports this ambient mode where you don't have to worry about restarting your application pods just to inject this sidecar into your as a service mesh component as part of your application stack. So I think that was great news. What I took away from this episode was Christian, right? He with his Global Field CTO title, I think he talks to a lot of customers, and the perspective that he brought in around platform engineering and how it's a mix, right? We can't shift left a lot or even go back right,
or too far.
We have to find somewhere in the middle where it's not all on the developers, it's not all on the administrators. Like, okay, you can have like Istio can be installed as part of the platform whenever you are deploying a cluster, but then the developers should be able to define their own policies. And I know we discussed that as part of like the Istio configs, and developers can define which services are supposed or not supposed to talk to each other, to other services, things like that. So I think it is that shared responsibility model whenever people are building these different IDPs and integrating service mesh as part of that.
Yeah, absolutely. I think building on top of the whole talking to customers thing, I think those, the years and years that, Christian has sort of had experience both at Red Hat and beyond and at Solo, right? The whole idea behind seeing how customers are implementing it, seeing how customers are struggling, what things are too much, right? They, we talked about, Istio initially being, or Linkerd being, doing too much, having too much in there, and really seeing how that's boiled down over the years, and kind of coming back to the cake stack that we talked about, right? Having a CNI layer that, technically you can choose from, the Istio layer or ambient mode, Kubernetes and Envoy and Spiffy, right? I think it shows definitely the maturity of sort of how it's evolved over time, both through seeing how much people really want to configure themselves. Obviously, platform engineering and sort of the later pushes pushed into making sort of that a bit more of a reality of what the the quote unquote golden path looks like, but also getting sort of this stack that's sort of a well-known working starting point, with flexibility in it. I think that speaks to the concepts behind platform engineering itself, because that's not a one size fits all thing. You can't just throw any platform engineering, right? There's still guardrails that sort of you're defining, or maybe the platform is defining itself. And the stack itself is sort of saying, here's a known working layer and layers, I should say, that work well together and give you, sort of guardrails for where to start and all those things. So yeah, I think that's a lot to take away. I think that just shows where we've come since, early days of service mesh.
No, and I agree, right? Like the cake stack, apart from it being a great sticker to have at the next KubeCon, as you said.
It sounds like a delicious sticker. I still think that's a good idea, Christian.
Just that these things have been kind of tested together by the community. So if I'm an organization looking to get into or implementing service mesh, right, I know that all of these things have been kind of tested by the community. I don't have to go and figure it out on my own or figure out what other components I need. I think having a standardized framework definitely helps. That's why the LAMP stack that we discussed was so popular back in the day. So yeah, this is awesome.
You say back in the, I mean, that's true. I guess it is a little bit back in the day.
At least back in the day for me, I don't code anymore, right? So like at some point I did, but like not anymore.
I love it. Cool. Well, I hope you all enjoyed that episode. I think Christian had a lot of great things to say, and hopefully you'll go reach out to some of the communities. We'll again make sure to link those spaces he talked about, and if you're local to the area, Dev Summit Boston sounds like a cool place to go learn more and hear him talk if you want to. But as always, please share the podcast with your colleagues and your friends, maybe not your family if they're not into this kind of thing, but
come
on. Join our Slack. We're always looking to interact with you there or get some ideas. I think one thing I'd love to hear is if you are currently or have been in a situation where maybe you were part of a team that over rotated on the whole shifting left, or maybe you have some ideas. I think that'd be a really cool conversation to have on this show, to give that perspective of sort of like being in the weeds of it, because we hear about it, we know it exists, and I think we're still trying to find the right place, and it's different at every shop. So come talk to us. I think that'd be a lot of fun. Cool. Well, that brings us to the end of today's episode, Bhavin. I'm Ryan.
I'm Bhavin.
And thanks for joining another episode of Kubernetes Bytes. Thank you for listening to the Kubernetes Bytes podcast.